parameters of motion. In the parameters of motion, we discussed about distance and displacement, as well as speed and velocity. In that velocity, in earlier video we discussed about speed and velocity also. The continuation for the velocity is whenever the average velocity and instantaneous velocity we discussed here, average speed and average velocity will be equal when the body is moving along a straight line without changing its direction, and instantaneous speed which is equal to instantaneous velocity in magnitude. Because of whenever the body is moving along a straight line, then here we discussed about that when the body is moving along a straight line, distance is equal to displacement. Distance and displacement will be both are equal. As well as here, when the body is moving along a straight line, the average speed and average velocity is also equal in magnitude. In that case, instantaneous speed is also which is equal to in instantaneous velocity in magnitude. So here is that the instantaneous velocity in magnitude is equal to instantaneous speed. Some of the about the velocity and average speed, and about the some of the important points we are going to discuss. And also, if the particle moving along a straight line, means if the particle is moving along a straight line, without changing its direction, then its average velocity and average speed, which is both will be the equal. So in this case, when motion in a straight line, we will discuss the average speed and average velocity both are equal. We will consider as both are same. So in the motion in a straight line. So in this case, in other cases, the average velocity is always less than the average speed. So that's why we can get that average velocity by average speed, which is less than or is equal to 1. Means if the body is moving along a straight line, then at any point the velocity will be same, as well also instantaneous speed also same. The distance is equal to displacement. The average velocity and average speed also which will be equal whenever it is traveling straight. Then here in uniform motion means the body it travels equal distances in equal intervals of time. Intervals of time, the distance s is equal to velocity or speed into time. In this case, for circular motion, means when the body is moving along a circular motion, which is having this distance will be this, the circumference will be this circumference, total length of the circumference will be, means the particle travelled the circumference. Whenever it is in circular motion, the total distance which can be taken is 2 pi r. So that's why distance can be taken 2 pi r is equal to v into t. Because of here, this is the radius of the path which is having travelled the radius of the path when the body is in a circular motion, uniform circular motion. When the body is in uniform circular motion, then it's equal to 2 pi r is equal to vt, means this will be the distance travelled by a particle or an object, and this will be velocity or speed, and t be the time taken to complete this circle. Here is that we are going to know the what is average speed and average velocity in some cases when the particle is travelling in distances, some of the distances in a different times of interval. Means here we are going to know body covers the distances are s1, s2, s up to so on to sn distances in with a speed v1, v2, vn up to so on vn in time intervals t1, t2 up to so on to tn. We know that what is average speed? The average speed which is equal to the total distance travelled by total time taken to travel the distances is called average speed, that is s by t. Here is that the total distance travelled is s total s1, s2, s3. So that's why we are writing that s1 plus s2 plus s3 plus up to so on to sn by the total time taken. The time intervals are t1, t2, t3 up to so on to tn. So we are taking that t1 plus t2 plus t3 plus up to so on to tn. Then but we know that from the equation we have that s is equal to v into t, means when the body is in uniform motion. When the body is in uniform motion, then we can write that here t is equal to s by v. T is equal to s by v. In this relation, we are writing that t1 is equal to, we can write that s1 by t1 plus s1 plus s2 plus up to so on to sn by s1 by v1 plus s2 by v2 plus s3 by v3 up to so on to Sn by Vn. Sn by Vn. In case of, if the distances are equal, means whenever the body is in motion, whenever it is in uniform motion, the distances S1 is equal to S2 is equal to up to so on to Sn is equal to S. Then if we consider that, then this total becomes a number of S. So here is that we are taking only two distances we are taking. If in case of two distances, if we take S1 plus S2, then here S1 plus S2 is equal to S. If we consider the body travelled from the S1 S2 with the distances with velocities V1 V2 in time intervals T1 T2. If we take 2, then we can get that is S1 plus S2 means 2S by these are all we are multiplying. Here is that S by V1 plus S by V2 by taking outwards, the S will become, that is 1 by V1 plus 1 by V2, then S get cancelled. By the LCM, doing LCM, 2V1 V2 by here V1 plus V2 we can get. V1 plus V2 we can get whenever the S1 is equal to S2 is equal to S. If in case of the body covers different distances with different speeds, we can get that 2V1 V2 by V1 plus V2. In case of 3 displacements, we can get that is S1, this is of 2 displacements. If in case of S1 is equal to S2 is equal to S3 is equal to S, then we can get from the 3 displacements is there, then we can get that 3V1 V2 V3 by V1 V2 plus V2 V3 plus V3 V1 with the average speed. Here is that we can get the total values, further values, continuation values whenever we substitute the values, where this is the average speed. Whenever the different distances with the different speeds. In this case of, if the distances are equal, then this will be the equation for 3 distances taken, then 3V1 V2 V3 by V1 plus V2, V1 V2 plus V2 V3 plus V3 V1 be the equation. In this case also we can find out that for the different speeds in different times of interval, we can write that different speeds in different intervals of time. Different time interval. Then we can get, already we know that average speed. The average speed will be the average speed V average is equal to, we know the formula, that is S by T. From that relation already a body covers S1, S2, S up to so on. Sn is this considered this equation. This is the one case and this is the second case. Consider this is second case. In that case, we know that the total displacements are S1 plus S2 plus up to so on to Sn by time intervals are T1 plus T2 plus up to so on to Tn. In case of, if in the different speeds in different times of interval, we can get the different speeds. We know that from the formula V is equal to S by T, from the relation S is equal to Vt. From this case, S1 is equal to V1 T1 and S2 is equal to V2 T2. From that as well as we can write that V1 T1 plus V2 T2 plus up to so on to Vn Tn by here T1 plus T2 plus T3 plus up to so on to Tn be the relation whenever the body moving with different speeds in a different intervals of time. Then if in case of the unequal intervals of time, means whenever the body is travelling in equal intervals of time in uniform motion, if the body is in uniform motion, it covers equal distances in equal intervals of time. Then in equal intervals of time in uniform motion, T1 is equal to T2 is equal to up to so on to is equal to T if we consider T. Then if in case of we will substitute T, then we can get that V average is equal to here the T of V1 plus V2 plus up to so on to Vn by here is also we can get that number of tens T up to so on to N. So that's why a number of T's. means the number of time intervals. So that's why number of time intervals, then T get cancelled. From this relation we can get that V1 plus V2 plus up to so on to Vn by n, means V average is equal to, we can get that V average is equal to, we can get that the sum of the, this is called as the arithmetic mean of individual speeds. This is also called this is the, it is the arithmetic mean of individual speeds. This is the arithmetic mean of it is also known as the arithmetic means of V average is equal to V1 plus V2 plus up to so on to plus Vn by n. This is the arithmetic mean. Arithmetic mean of individual speeds. Once again, when the velocity, average velocity and instantaneous velocity will be average velocity, we discussed about it, and the average velocity which is equal to average speed whenever body is moving along a straight line without changing its direction, until it's changing its direction, the average velocity is equal to the average speed. In other cases, average velocity is less than the average speed always. So that's why we wrote the earlier that average velocity by average speed less than or is equal to 1. From that relation, if the body is moving, the distances are s1, s2, s3, s up to so on to sn, then with velocities, speeds v1, v2, v3 up to so on to vn, in time interval t1, t2, t3 up to so on to tn, number of times, number of distances, number of with number of velocities. Then if the body covers different distances with different speeds, then average speed is equal to, we know that the formula, the total distance travelled by total time taken. The total distance travelled by total time taken will be taken as a S by T. So here is the distances which are taking, that S1, S2, S3, so that's why we are substituting that we are summing the S is equal to S1 plus S2 plus S3 up to so on to Sn is the total distances travelled by the body, and the time taken by the body is T1 plus T2 plus T3 up to so on to Tn. But from the relation we know that, from the relation S is equal to Vt, from that relation we know that T is equal to S by V. From the relation T1 is equal to S1 by V1 and T2 is equal to S2 by V2. Like that we are substituting in the instead of T1 we are writing S1 by V1 plus S2 by V2 up to so on to Sn. If in case of the uniform motion, equal distances travelled by a body, in uniform motion equal distances travelled by a body, then so that's why we are considering that S1 is equal to S2 is equal to S. In that case, the S, whenever we substitute that values, the S plus whenever we are only taking the two measurements only here, so S1 plus S2 then is equal to S, then we can get that S1 plus S2 the 2S by whenever we take the S outside, then we can get 1 by V1 plus 1 by V2. So S get cancelled, we will get that by doing LCM 1 by V1 plus 1 by V2. By doing LCM we can get a 2 V1 V2 by V1 plus V2, like 2 by V2 plus V1 by V1 V2, like that. From the relation we can get a 2 V1 V2 by V1 plus V2. If in case of the three distances we are taking that the S1 plus S2, S1 is equal to S2 is equal to S3 is equal to S, then the formula will be 3 V1 V2 V3 by V1 V2 plus V2 V3 plus V3 V1 with the equation. If the body is moving with different speeds in different interval of time of interval, then we can get that we know the formula of average speed will be V average is equal to S by T. From that relation, the sum of the individual distances, that is S1 plus S2 plus up to so on to Sn, and the time intervals are T1 plus T2 plus up to so on to Tn. With that we know the formula, that is V is equal to S by T. From that relation we are writing that S1 is equal to V1 T1 and S2 is equal to V2 T2. From that relation we are substituting V1 T1 plus V2 T2 plus V2 up to so on to Vn Tn instead of S1 S2. Then from that relation, if in case of in uniform motion the body taken time, equal time of intervals during its motion, so that's why that T1 is equal to T2 is equal to up to so on to is equal to Tn is equal to T. By substituting the values we can get the t outside because of all the terms having the same component, same t. So t get cancelled. Here is the number of t's are added, so that's why n into t get cancelled. Finally we get the relation V average is equal to V1 plus V2 plus up to so on to Vn by n be the average velocity whenever a body is moving different speeds in a different intervals of time. This is the relation. If in case a body is moving different distances with different speeds, then we can get the value 2V1 V2 by V1 plus V2 be the relation. This is about average speed and velocity. Next we are going to know what is the change of velocity, means whenever the velocity is increasing means acceleration, or if the velocity is decreasing then it is called as retardation or deceleration.